Alrighty, my friends, welcome back to the second part of the videos for this week. And it's really just stemming off of that similar idea that we were just talking about with evolution, but now applying it to multiple species and how that can come about and kind of how different species can also help each other evolve, which is really quite fascinating. And this is basically the definition of something called coevolution. It's very similar. It's the same sort of idea as evolution. Now you're just doing it with multiple different species. So the definition that your book provides is that two species each provide the selective pressure that determines which traits are then favored by natural selection in the other. So make sure that this definition makes sense to you. Maybe pause the video, kind of digest what you think this means, maybe read the section in the book again real quick. So really just try and make sure that it's fully there in your mind. And what we can consider here are predator and prey adaptations. You can basically think of this as a coevolution arms race. So the predator has to be better adapted to catch their prey or catch the other one, or predator or prey have to be better able to escape their predators, right? So it's really kind of fascinating, and all these different sort of little modifications that can occur for different animals to be able to either find their prey better or escape their predators better. And these adaptations are, of course, based on selective pressures of the other population. So some adaptation, of course, is a genetic trait that helps an individual survive and reproduce. So let's see. So say, for example, what are some adaptations here? So cats, for example, wild cats in particular, kind of where our domesticated cats came from. But all cats have this adaptation in their spine that allows for this contraction and retraction and a little bit more wiggle room basically in their spine, so that they're able to run really fast and kind of watch a cat run. It's really quite fascinating. Or a cheetah in particular is a great example of this. And so that adaptation, that trait, has allowed them to be able to survive and hunt and run 75 miles per hour, being the fastest mammal on Earth, that kind of thing, right? So kind of really quite fascinating. So some other predator strategies out there would be, of course, to pursuit or ambush, right? So what do you think would make some predators more effective at pursuing or ambushing a prey? I encourage you to think of several ideas on your own. And in this particular case, I'm very fond of the bluefin tuna, which is the picture in the background here. A very, very beautiful fish, is gigantic, or can grow to be extraordinarily larger than you would think, over 3 meters long, I think in some cases, pure muscle. They can swim extraordinarily fast. So what do you think would make them such an incredible predator? Having that speed, having that muscle, being able to travel long distances, things like that. It's really quite fascinating. And what you can kind of see here a bit is even some of on the back of their tail here, these little spikes that can perhaps be useful for their speed, or the smaller fins, just the shape of the animal in general to make them go fast through the water. There's some really cool videos out there too where someone is in a boat and they're kind of putting bait out into the water, and you can see the bluefin tuna skirt across the surface of the water but not disturb the water at all. It's really, really wild. I'll try to remember to link that with the videos as a little extra video, because I think it's freaking crazy. But, considering other predators, right? Think of other species like owls or hawks, geckos, snakes. How are they more adapted to pursue their prey, right? Owls have gigantic eyes. Hawks have incredible eyesight. Snakes, have venom. It's really just consider a lot of these different ideas. It's really quite fascinating. Then the prey, right? These poor little innocent creatures are the ones that are being eaten. So what sort of defense mechanisms could they have against predation? I want you to consider traits that, would make, you're best suited to avoid being eaten. And what traits would have to evolve to be able to employ these strategies, right? So some ideas here would be fleeing. So how good are you at running away? Mechanical defenses like quills of a porcupine, or having a shell like an oyster or clam or abalone. Living in groups is huge. I know I talk about the ocean all the time, but even in this picture in the back here, which are of herring, which are what bluefin tuna really enjoy eating. It's one of their favorite. Or maybe this is mackerel, actually. Excuse me. I apologize. This is mackerel. But living in groups or being in schools, as you may have heard it called, is also huge for, if you have a big group, the less likely you are to eat the entire group. Camouflage is a big thing here as well. Fascinatingly enough, with a lot of creatures in the ocean, they have coloration varieties. So think of like a great white shark, for example. You have a really dark top of the body and a really light bottom, like belly. So if a fish is underneath the shark and looks up, the light that they would see, the lightness of the shark's belly would just look like the sun coming through the top of the water column. Or alternatively, if you're a fish swimming on top of a shark and you look down, you would just see darkness of the top of the shark just blending in with the darkness of the abyss of the ocean. Other animals in the ocean are also colored like that, but that might be one that you could think of. And also chemical defenses, kind of going back to what I talked about earlier in the previous video of poisonous frogs, right? They have glands on their skin which emit poison. That could be an example there. Then also what we tend to forget about are our lovely plants here. So the plant defense against predation, they can't flee, right? They can't get out the way. They can't grow legs and move. So some adaptations that plants have been able to employ are spikes or thorns or leathery leaves or like a thicker wax or poisonous or being unpalpable. The picture in the back here, this is of a cholla cactus, also known as the jumping cactus. Not a piece of cactus that you want to mess around with in the state of Arizona. It's incredibly unfun. 0 out of 10 recommend. So for all these defense examples here, I really want you to think about other plants that you may be aware of that employ these various strategies. So consider that. Going back to this idea of coevolution, right? We already talked about these first 2 bullet points. But they really just want to be best adapted to survive and reproduce. But what's fascinating is that the predator and prey populations don't consciously try to change, right? So prey species don't try to develop toxins, but rather it's a random mutation that produces the toxin, which makes one organism better able to resist predation and thus pass along that trait to its offspring. Similarly, a predator doesn't try to develop a resistance to a toxin. However, those not affected by the toxin due to a random mutation will survive and pass along these genes. So this is where genetic variability is really, really important once again. So this will be able to adapt to various predators, right? Like humans, we don't just eat one type of meat or one type of plant, right? We have a variation ranging from beef to pig to chicken. Those are kind of the main ones. And then, various types of fish. Gamey meat like elk or deer, if people are hunters, it's a very large variety, and that, kind of helps us live, thrive, and survive. So what happens when you are not able to adapt to the environment or an invasive predator? Well, you go by from our planet, right? It's a term called extinction. So the completely eliminated as a species from our planet. So this can occur because of genetic variation being very low, or there's a sudden change in the environment, which would make it difficult for a population to evolve, right? So this is especially true for species with really, really long generational times. Populations that reproduce really quickly, like insects or bacteria, can have more opportunities for genetic variation, but things like large mammals like ourselves take decades to reproduce and to like really build a whole community and population, right? Maybe you've heard of like cockroaches, how those will just like forever be an insect that won't like survive anything. There's a reason for that. They mutate, or they reproduce a lot. And so sometimes they can be all wiped out before they can reproduce at all, which of course is a big issue. It's something that's being talked about a lot right now in the modern conversation with climate change, and basically making the environment not able for different animals to reproduce and keep their young on a solid piece of ground, like polar bears, for example. So what I would love for you to do, of course, is to review the K and R selected species from population ecology and try to like maybe tie that in a little bit to this idea of extinction. So like who would be most better suited for that? Extinction also is something that's nothing new, just like natural selection and evolution. But aside from mass extinction events, the background rate of extinction is actually quite low. So we've had basically 5 main extinction events, mass extinction events, over our geological time periods. Mostly, we believe, due to climatic changes, due to geological conditions. So gigantic volcanoes continuously going off to change the climate of our planet, or meteor strikes, which we believe is what wiped out the dinosaurs, right? So so we've had these periods in time throughout the Earth's life. And natural disasters, are a cause of mass extinction, of course, but today, human impact appears to be the causing of another mass extinction. Again, due to climatic changes, but not geological time span ones, but human time span ones. Geological time, as kind of trying to be indicated by this graph here, I know it looks really small, but like it's a really large amount of time, and it's really quite wild. But what we're doing to our planet now for anthropogenic climate change is making changes to our environment at such a faster time scale than evolution is able to keep up. So that's the big concern, and that's essentially what we believe is happening now. So what other factors might make a population more vulnerable to endangerment or extinction? They exist only in an extremely small area, or maybe they require an extremely large range. Perhaps they live on an island. They have low reproductive success, maybe specialized breeding areas or specialized feeding areas, etc. So how do you think each of these characteristics could lead to an endangerment or an extinction? I would like for you to try to come up with a specific organism that fits into at least one of each of these categories. Additionally, thinking of this idea, there's, the extinction lessens biodiversity, which can potentially be really harmful to human populations. And I want you to also consider this term biodiversity and what you think it means, because our next lesson, our next week, is going to focus particularly on biodiversity. So if you've heard of that term before, perhaps in a previous science class, or you don't even know what that means, that's okay. We'll learn all about it. But I want you to maybe start thinking about that idea, and we'll approach it when we come back together next week. Thank you again so much for your watching and for your time and attention, and I hope you have a wonderful rest of your day. Thanks.